Hi, I'm Deepika and I'm an 8th grader in Orlando, Florida. The real reason I've always loved STEM is because every day it's a new challenge. I fell in love with STEM when my dad had a surgery that's performed by robotic equipment. I realized that technology could save people's lives. Ever since, I've been trying to get more involved in STEM. I heard about Project CS Girls from an email sent about it from Broadcom, and I wanted to get involved. Closing the gender gap in STEM settings is something I feel extremely passionate about, now that I've experienced firsthand what it feels like to be the only girl in the room. So, let's hear about my project. High-speed internet from streetlights? That's right. Wi-Fi or light fidelity is an emerging technology in optical wireless communication. Conventional wireless fidelity technology or Wi-Fi uses radio waves to transfer data. Wi-Fi uses light waves. LED bulbs whose light intensity can be changed very rapidly are used to transmit data to a photodetector, which receives the data and converts it to a streamable format. However, the main disadvantage of Wi-Fi in respect to Wi-Fi is its inability to pass through walls. While this does make data transfer more secure, it can't accommodate as many people at a given location. But most importantly, Wi-Fi creates a safer setting for patients if used in hospitals. It won't interfere with radio waves produced by other medical equipment like MRI scanners. My first goal for my project was to create a Wi-Fi system capable of transferring audio. My second goal was to innovate methods to replicate using Wi-Fi in outdoor, home, or office settings. This may be important in evaluating the feasibility of using street lamps as Wi-Fi routers. I use sound transmission as the way to measure the different qualities of data transfer. I built the Wi-Fi transmitter, wherein I fed the audio signal from the sound source to two LED bulbs. The LED bulbs would blink on and off very rapidly in response to the sound signal. And for the receiver, I use a solar panel which I connected to a speaker using a standard stereo cable and stereo jack. To record the intensity of the sound, I use an app called the Neo Sound Level Meter, which detects the LAEQ, or the A-Wade equivalent sound level. I created an input audio signal using the Anvil software. In this case, I use C5, which is the middle C of the piano, and the sound level at 100%. Next, I wanted to study the effect of barriers on the sound intensity. If Wi-Fi is incorporated in home, office, military, or hospital settings, this would be a very important consideration. So I used paper and glass, both common partitions and decor in these settings. But let's say we were using Wi-Fi at street lamps, where the data transmission is affected by environmental conditions. To replicate fog and other contaminants, I wrote a Python program using Turtle graphics. It first draws a rectangle the size of the solar panel, then covers it with circles covering X amount of area. I printed out the graphics on transparency sheets and put them on the solar panel. I think that Wi-Fi is the future of communication in third world countries. Several patients die from the lack of a steady communication system between nurses, doctors, and patients. Also, road traffic is responsible for nearly 1.2 million deaths annually in middle and low-income countries. LED-based headlights can use Wi-Fi communication from one headlight to another. Wi-Fi can help transfer data quickly and more securely, leading to a safer world. I hope you enjoyed learning about my project and its societal impact.